There are a few animals alive today as awe-inspiring as whales. Massive, intelligent, diverse, and majestic, these titans of the oceans are the largest animals to have ever lived on our planet. They are our deadliest predators, our gentlest giants, and everything in between. Whales also happen to have one of the most fascinating evolutionary tales in all of natural history, with some growing to enormous shapes and bizarre sizes across the Cenozoic Epoch. In fact, it only took around 25 million years after the extinction of the dinosaurs for whales to evolve from small, terrestrial, dog-like animals to colossal marine apex predators, the largest animals on the planet. Today, we will be taking you back to the oceans of the Pliocene epoch to meet a whale unlike any other. Livyatan Melvillei was a terrifying marine apex predator, one that was at home in the open oceans and coastal waters, where it specialized in hunting very large prey items. This ancient sperm whale was not alone in these seas, holding its own against one of the most infamous predators in all of natural history, Otodus Megalodon. For almost 5 million years, these sea monsters interacted, competed, and possibly even attacked one another in the waters of the Cenozoic era. Sit back and relax as we bring you face to face with this colossal whale. Livyatan melvillei was a prehistoric cetacean in the superfamily Physeteroidae, a group which included the largest of the toothed whales, the sperm whales. Modern sperm whales have 3 species, the sperm whale and its dwarf and pygmy cousins. The former is one of the most adept apex predators in the world's oceans, frequently diving down to abyssal depths to hunt giant squid in near-legendary pitch-black battles. Adult male sperm whales have been known to reach maximum lengths of 19 meters or 62 feet and can weigh up to 57 tons in rare circumstances. Whilst all 3 modern sperm whales belong to the family Physeteroidae, it is not known if Livyatan belongs to the same classification. Scientists are not currently certain on where Livyatan sits in the sperm whale family tree, and as such, it has not been assigned to a distinct family. Livyatan melvillei is known primarily from the fossil-rich rocks of the Pisco Formation in what is today modern Peru. It lived from the Tortonian stage of the Miocene epoch, roughly 9.9 million years ago, up until the Zanclean stage of the Pliocene epoch, around 5 million years ago. These late surviving specimens are debated as to whether or not the fossils show Livyatan or a closely related animal that survived slightly later into the Cenozoic. Although Peru's fossil formations are closely associated with this whale, it is thought that, similar to modern sperm whales, Livyatan may have had a global range, spanning all of the planet's deep and open waters, where they could enjoy wide open spaces and plentiful sources of large prey animals. While Livyatan was a more adept hunter of marine vertebrates than the modern sperm whale, it was slightly smaller, estimated to have measured around 17.5 meters at its longest. Still, this is an immense size for an animal to have attained, and while it is slightly smaller than its modern cousins, this would still make Livyatan one of the largest known predators ever to have lived on planet Earth. In life, it would have looked rather like a modern sperm whale, but with a shorter skull and somewhat bulkier body. While modern sperm whales are easily identifiable by their colossal, elongated head, Livyatan would have been blunter at the snout with more powerful jaws for tackling stronger prey. Inside Livyatan's mouth were rows of sharp, conical, outward-facing teeth. These teeth are, at the time of writing, the largest known biting teeth in any organism known to science and would have been used to grasp and tear at large prey items. The skull alone was at least 3 meters in length and was equipped with extremely powerful muscles connecting the skull and the jaw. Reconstructed skulls of these whales show just how terrifying these animals were, looking almost like a make-believe creature from a sci-fi movie, rather than a living, breathing whale. Unfortunately, most of the skeleton of Livyatan is still unknown to science, and paleontologists have had to primarily work off of the skull, jaw, and tooth fossils that have been uncovered, some of which are in excellent condition. Scientists have been able to estimate the size of this whale by comparing the size of the skull with the body proportions of living and extinct sperm whales, which has provided them with the huge size estimations. The teeth of this whale obviously belong to a strictly carnivorous animal, and as such, it would have needed a massive body to provide propulsion and force to its hunting techniques. As such, Livyatan is often reconstructed by scientists and artists with a body packed full of blubber and muscle, one that was capable of defending the animal from attackers and the elements, whilst permitting the speed necessary for a hunter of large marine creatures. Like modern sperm whales, it is theorized to have had very large tail flukes and powerful fins to help push it through the water. Livyatan is not only the most common in the Pisco Formation of Peru, it was initially discovered there too. The first known fossil content, which would later be attributed to the whale, was discovered by Dutch researcher Klaas Post from the Natural History Museum of Rotterdam within the rocks of a coastal desert around 22 miles southwest of the Peruvian city of Ica. Post happened to find them by chance on the final day of a field trip in November of 2008, observing odd shapes in a rock which later revealed to be a partial skull, complete with jawbones and several teeth. Upon making his discovery, Post brought his find to the Natural History Museum in Lima, Peru, where they were prepared and studied. The original Livyatan fossils can still be viewed there today. In July 2010, the whale was officially named and described. Olivier Lambert and his team of vertebrate paleontologists from the National Museum of Natural History in Paris, France, named the whale Livyatan Melvillei, taking its generic name from the biblical sea monster Leviathan and the specific name from Herman Melville, the author of the literary classic Moby Dick, a fitting name for a prehistoric apex predator whale. One problem arose, however, in the fact that Livyatan was already assigned to a synonym of the genus Mammoth, the mastodons. The same scientific name cannot be used in reference to more than one organism as to not cause confusion, and so a different name needed to be chosen. Lambert and his team instead chose to give the whale the original Hebrew name of the biblical sea monster, Livyatan, and kept the specific name Melvillei. It's certainly one of the more impactful and dramatic names given to a prehistoric animal to date. Over the next several years, up until very recently, further fossil content confirmed to belong to Livyatan Melvillei would be discovered further south, down the coast of South America. Teeth are by far the most common fossil material to be uncovered from the whale, some of which measure over 30 centimeters in length each. It is known for a fact that Livyatan's range extended as far as central Chile, but subsequent discoveries have been made which may vastly expand this. Since the late 2000s, fossilized sperm whale teeth that match the size and shape of Livyatan have been cropping up in other localities. An isolated tooth is not usually enough fossil content to determine the exact species of an animal, and so it has not been entirely confirmed whether these teeth belong to Livyatan or a closely related species. But it is known that giant sperm whales were patrolling much of the southern hemisphere in the late Miocene and Pliocene epochs. Fossilized teeth which may belong to Livyatan have subsequently been found in southern Argentina, South Africa, and the southeastern coast of Australia. Even more recently, in 2023, possible Livyatan teeth have been found in California, challenging the idea that this whale inhabited only the southern hemisphere. It remains to be confirmed where exactly this whale lived, but it looks likely that it may have been very widespread, ruling the Earth's oceans as a major apex predator in the middle to late Cenozoic. Livyatan was, without a doubt, a fearsome apex predator that rivaled Megalodon in strength and hunting capability. Unlike the modern-day sperm whale, Livyatan is thought to have occupied the surface levels of deep, open ocean waters as an adult, where it specialized in hunting a variety of large marine vertebrates. Livyatan's prey is thought to have included baleen whales, dolphins, pinnipeds such as seals and sea lions, and sharks. It is not thought to have been a picky eater, however, and would have been capable of hunting any large marine vertebrate that it could handle. Some of the baleen whales it is thought to have preyed upon were large, measuring up to 10 meters in some cases. Some paleontologists have theorized that Livyatan may have lived a life not unlike the modern-day killer whale, or at least occupied a similar ecological niche as the top mammalian predator in its ecosystems. Given the sheer size of this whale, however, it is likely that it was a solo hunter, unlike killer whales which famously hunt in pods, working together to bring down much larger baleen whales. Study on Livyatan's skull and teeth point towards this animal being a relentless pursuit predator, spending considerable amounts of time chasing after a catch in order to drain its energy. When a hungry Livyatan caught sight of a whale it considered to be a suitable meal, it would likely maintain a steady, fast speed, chasing after it through the endless blue ocean. Livyatan had patience and stamina on its side and would probably have been capable of outlasting many large animals it shared the waters with as it followed its fleeing victim. These hunts may have lasted hours at a time in extreme cases, which may have also seen the predator taking action to end hunts early. When a prey item began to tire, Livyatan could strike with its gigantic teeth, tearing at the flesh of its victim as it slowly grew more and more exhausted. Some theories state that Livyatan may have been able to ram its target with its tough, blunt head, further wearing out its catch to bring it down quicker. Eventually, when its prey became too weak to continue swimming, Livyatan would use its immense body weight to prevent its prey from taking another breath, ultimately drowning its victim if it hadn't already delivered a killing bite or blow. Similar to a modern sperm whale, Livyatan is known to have possessed a spermaceti organ, a feature that is entirely unique to sperm whales, both prehistoric and extant. The spermaceti organ in modern sperm whales is located in their huge bulbous heads and consists of huge channels of liquid, mainly oil and wax, that are segmented into chambers by tissue in the animal's head. Modern sperm whales use their spermaceti organs to echolocate their prey in the dark waters they hunt in, generating loud clicking noises which travel through the liquid in their heads. These clicks are then reflected into the melon, a mass of fatty tissue on the whale's forehead which focuses the clicking sound into a beam. This beam reflects off a potential prey item in the dark depths of the ocean and is received by the whale as it bounces back towards its lower jaw, absorbed by fatty tissue which takes the sound up to the whale's ear. It is a complex system that has evolved over millions of years and allows the whale to build up a picture of its surroundings without being able to physically see them. Using this method, sperm whales can locate and even stun prey before they close in with their massive jaws. Livyatan may well have used its spermaceti organ in a similar fashion, generating a series of noises to find prey in darker waters. However, Livyatan is thought to have lived primarily in the surface waters of the deep, open oceans and may have only needed to echolocate in certain circumstances. It seems more likely that Livyatan, if it used its spermaceti organ in hunting, may have used it primarily as a weapon, creating focused barrages of intense, loud sound, aiming it at its prey in order to slow it down or stun it entirely. Other theories have been put forward as to how this whale might have used its spermaceti organ, and a popular running idea is that Livyatan used it to display to potential mates. Using an array of clicks and whistles, the whale may have been able to project its voice deeper into the great blue void of the ocean, calling out for a member of the same species to avoid waiting a long time to happen across one. It may also have doubled up as a tool to fight off rival males when a female did answer the call. Finally, the whales may also have used their spermaceti organs as a buoyancy aid. They were possibly capable of altering the temperature of the wax within their heads at will. Colder wax increased the density of the whale's head, meaning that it could dive deeper in the water with ease, whereas warming the wax would have allowed it to reduce its density, rising to the surface quickly to take a breath. Details on the social lives of Livyatan are few and far between. Behavior is hard to infer from fossils alone, and scientists must use living animals as a comparison in many cases. It may be the case that, like modern sperm whales, Livyatan may have lived in pods. Today, pods are mainly formed of females and young individuals, with young males breaking away from the group once they reached adulthood to form bachelor herds. Older males will then separate once more, living solitary lives. These whales will typically only come into contact with others during the breeding season. However, Livyatan was certainly not a modern sperm whale, and due to its different habitat, lifestyle, and hunting preferences, scientists cannot say for certain whether or not these whales lived alone or in family groups. A solitary lifestyle may be more plausible for Livyatan considering its hunting methods, but whales can generally be very social animals. Like several groups of large marine animals, Livyatan mothers may have birthed and raised their young closer to shore in shallower waters where it would be easier to take a breath. As the babies aged, they may have gradually spent more and more time out at sea before taking to the endless, open stretches of blue for the remainder of their lives. While Livyatan is known primarily from Peru's Pisco Formation, there is a good chance that it inhabited the wider stretches of the world's oceans. However, the remains from outside of South America may belong to slightly different species of prehistoric sperm whale. To paint a more vivid picture of what life might have been like for the Peruvian Livyatan specimens paleontologists can be sure of, we will be focusing on the life and environment of the Pisco Formation specifically in this segment. The Pisco Formation's rocks are composed of sandstones, siltstones, conglomerates of sedimentary rock, and dolomite rocks. Research into these sediments, including analysis of the types of fossil animals found here, point to this being a marine environment, specifically a coastal region that spread out into open waters upon exiting a vast lagoon. Because of the transition between shoreline, lagoon, and open water environments, a great deal of animals have been found here, ranging from whales and dolphins to sharks, seals, and seabirds. It would have been an ecologically busy area with waters teeming with life close to the shore, which were taken advantage of by huge colonies of noisy birds nesting on the cliffs. These waters were also home to some unconventional residents, including an array of bizarre mammals unlike anything else found in waters elsewhere. Tough grasses would have grown on the beaches and cliff tops here, whilst huge strands of kelp provided cover for smaller fish beneath the waves. The first thing a theoretical time traveler to the Pisco Formation would notice about this environment would have been the birds. Thousands upon thousands of them would have created huge cacophonies of sound as they communicated with one another on the rocky beaches, on the cliff tops, and over the waves as they built their nests, hunted fish, and displayed to one another. Some of the most common fossils here represented genera of birds that are already familiar to modern scientists, such as cormorants, fulmars, gannets, and boobies. One species of the latter, Ramphastosula ramirezi, is famous for its huge, thick beak, which would have been a useful tool in snatching fish and crustaceans from the waves. As such, this unusual seabird has been nicknamed the toucan-billed booby. On the rocky shorelines, occasionally dipping in and out of water to catch fish and squid, lived vast colonies of penguins. 4 species lived here, all of which were members of the genus Spheniscus, the banded penguins. Spheniscus megarampus is one of the most notable species here, being the largest known species of banded penguin, one that boasted an abnormally broad beak that would have been capable of delivering a powerful snapping bite to any fish it was able to catch. The Humboldt penguin, a currently extant species that is a familiar face in many zoos and aquariums, lived here too. High above them all flew one of the most spectacular sights in the prehistoric world, Pelagornis, one of, if not the largest species of flying bird ever to take to the skies. This giant would have resembled a huge predatory albatross, and yet was more closely related to pelicans, the latter of which also found a home here. Below the surface of the water, the Pisco Formation was teeming with huge varieties of fish. All manner of piscine vertebrates lived here, from vast shoals of herrings and sardines to bizarre sea robins that crawled along the ocean floor on derived limbs made from their pectoral fins. Out in the open waters, swordfishes darted in and out of the herring shoals, spearing and slashing at the ethereal silvery balls of scales with their elongated bills. In the kelp forests below, eagle rays filtered the seafloor for crustaceans and other shellfish, cracking them open with their powerful jaws. Many species of familiar extant sharks inhabited these waters too, from the slow-moving sand tiger, a few species of speedy open-water mako sharks, through to the infamous great white. One shark here, however, stood out from all the others. Otodus Megalodon served as Livyatan main ecological competition, a gigantic shark that could contend in size with the mighty whale. Whilst no interaction between Megalodon and Livyatan have been preserved in the fossil record, there is no doubt that these two titans of the Pliocene seas encountered one another at least semi-frequently and almost certainly preyed on the same animals. The two may have had to fend each other off for food and territory, which would have been a rather evenly matched fight if it came to it. Megalodon, however, would have been able to descend deeper into the water column, staying submerged indefinitely. While Livyatan needed to ascend to the surface to breathe, it was more heavily built than the shark, and there's no saying what could have really happened if these two species came to blows. The Cenozoic is, after all, remembered for its mammals, and there was no shortage in the waters along the coastlines of the Pisco Formation. Whales of all shapes and sizes filled the seas. Fellow sperm whales Kogia danomurae and Choristocetus pescae, while much smaller than Livyatan, skulked in the shallows hunting fish and squid, whilst out at sea, Livyatan would have been joined by the likes of Ninoziphius. This huge beaked whale with long forceps-like jaws would have been a relatively alien sight in today's waters, with its barrel-shaped body and short tail. The kelp forests were occupied by the likes of Odobenocetops peruvianus, a small whale that resembled a walrus more than any other creature. With two tusks used for display and combat, this whale would have been a specialized feeder of shellfish on the seafloor. Out at sea, all manner of smaller cetaceans would have fallen prey to Livyatan. Dolphins such as Brachydelphis and Pliopontos would have traveled in small pods out in the open waters, whilst baleen whales such as Balaenoptera cyberi would have made for bountiful slow-moving meals for the giant carnivore. Paleontologists even have evidence of what may be an ancestral species to the killer whale in the Pisco Formation. Hemicentrichelys oligodon is one of the earliest known fossil orcas. The penguins that gathered in huge colonies on the rocky beaches of the Pisco Formation also needed to be wary of terrestrial predators, pinnipeds. These shorelines were home to Acrophoca longirostris, also known as the swan-necked seal, a large carnivorous ancestor of the modern leopard seal with a slender build and long neck. These seals would have been capable of taking prey both on land and in the water. and no doubt sent colonies of penguins running for their lives on many occasions. Several species of pinniped lived here, including true seals and sea lions. The most bizarre animal in the Pisco Formation, however, was one that you certainly won't see amongst the waves and shorelines of modern-day South America. Thalassocnus, a genus of large, semi-aquatic sloth. 4 species lived here, all of which are thought to have traversed land and sea in order to feed on aquatic plants in the kelp forests of the ancient Pacific. These unusual mammals developed heavy bones to keep them submerged, and wide snouts that were angled downward so they could pluck marine plants from the ground at the root. They're thought to have used their tails in a similar fashion to a modern-day beaver, and would have needed to be wary of sharks and toothed whales as they descended into the waves to feed. The evolutionary tales of the cetaceans, that is, dolphins and whales, is one of the most fascinating stories in all of natural history. The very first animals that can be associated with cetaceans have been found in Eocene sedimentary rocks in what is today India and Pakistan, and they look remotely nothing like modern whales. 59 million years ago, in the tropical forests of South Asia, lived an animal known as Indohirus indirae. No larger than a household cat, and looking similar to a modern-day mouse deer, albeit with a long snout and tail. This little omnivore patrolled the riverside woodlands of its ancient home, feeding on underwater plants, invertebrates, fish, and other small vertebrates. It was a hoofed mammal, specifically an even-toed ungulate, not too distantly related to hippopotamuses, which means that modern whales and dolphins are still technically classed as hoofed mammals today. This little mammal would lay the foundations for Livyatan to emerge in the future, despite looking more like a large rodent than a huge underwater behemoth. As the Eocene epoch progressed, the ancestors of whales would spend more and more time around the water, taking to it more confidently as species progressed. Some whales would take on a more predatory lifestyle, such as Pakicetus, which resembled a strange, semi-aquatic wolf. Further down the line, crocodile-like forms would arise, such as Ambulocetus, which spent huge portions of its life in and around coastlines of the ancient Middle East. Gradually, as whales spent more time in the water, their limbs would begin to change drastically. Their hind limbs would become smaller and smaller, eventually atrophying to nothing more than vestigial legs. The forelimbs, meanwhile, became well-adapted paddles, used for steering and propulsion in the water. This begins to become evident in Rhodocetus, whose limbs are much more paddle-like than its ancestors, although it still retained efficient hind limbs for paddling through the coastal waters. By around 40 million years ago, visibly recognizable whales evolved, giants that would take to the ocean permanently, losing the ability to return to land. These whales, the basilosaurids, would become the largest predators of their day, growing up to around 18 meters long in the case of Basilosaurus. Their long, tapering bodies were perfectly adapted to a life hunting at sea, and they fed on sharks, whales, and semi-aquatic mammals, much like Livyatan would in the future. The largest of the basilosaurids was Parusetus colossus, a giant discovered in 2023 that was capable of reaching an immense 20 meters from nose to tail. Eventually, cetaceans would split off into 2 distinct lineages, baleen whales and toothed whales. The first baleen whales evolved around 23 million years ago and became huge ocean-going filter feeders. In place of teeth, these whales developed baleen plates inside their mouths, equipped with fine hairs to filter out tiny organisms such as krill and plankton. These whales would eventually go on to become the largest animals the world has ever seen. Prior to the evolution of baleen, all whales were toothed whales, and many species following their evolution still continue to be. Toothed whales would eventually split off into many lineages, including the sperm whales, beaked whales, and dolphins, the former of which would eventually give rise to Livyatan. Today, whales are the largest animals in our seas, and everything started with those tiny hoofed mammals in the forests of India. Livyatan was, without a doubt, one of the most awesome predators to have ever graced our oceans. But sadly, there are none to be found in our oceans today. It is thought that Livyatan became extinct by the end of the early Pliocene epoch, when a cooling event stunted the diversity and size of many of the baleen whales it relied upon for food. As baleen whales began to temporarily disappear from Livyatan's waters, it had nothing to feed on and became extinct alongside its prey. This event saw the rise of cetaceans such as orcas take Livyatan's place at the top of the food chain, and they were perfectly adapted to hunting whales of all shapes and sizes, and did not need to rely solely on prey items of a certain size to sustain themselves. So then, as Livyatan disappeared, it gave way to some of the most striking, beloved animals of the modern oceans. With any luck, paleontologists will be able to discover more fossil content from Livyatan in the future, so more may be learned about this terrifying predator of the ancient oceans.